Hi, welcome back to another episode of Algebra in Words, the video series. We're going to continue looking at linear equations. What I have on the board is a typical type of question that you can be asked. So let's take a look. The question asks to give the equation of the linear equation that passes through this point, 0, 5, and is parallel to this line defined by y equals 1/3 x plus 4. Alright, so there's a couple little details that we need to pick out to do the problem. Now, first of all, the problem may specify what form they want the equation. Let's assume that it's going to be in the form y equals mx plus b, the slope-intercept form. Alright, so, and we'll find out, anyway, you'll see where it's going to go. So first of all, since it's going to be parallel, what do we need to remember about parallel and slope? Well, we need to remember that that's the slope, and for it to be parallel, it's got to be the same slope. Alright, so let's start off by just writing m equals 1/3. So we know we're going to use that. Alright, the next thing is, for a problem like this, think about this a second. You have a point, and now we have a slope. That should tell you to use the point-slope formula. I'm just going to write that formula right here. Y minus y1 is equal to m times the quantity x minus x1. I went over the point-slope formula briefly in the linear equations intro video, but let's just review it quickly. This is the point-slope formula, and you use it when you're given a point and a slope that you need to ultimately convert into another form of linear equation. Also, just to remind you that y stays y and x stays x, but y1 you put in a value from the point, which in this case would be 5. We'll put that in a second. You put the value of slope in for m, x stays x, and for x1 you put in a value for x from the point, which in this case will be that. So now let's plug in our values. Y stays y. For y1, we're going to put in 5. This should be minus equals m, which we determined to be 1/3, which we got from this because to be parallel, it has to be the same slope. Keep in mind, we can only get the slope when this equation is in the slope-intercept form, which it is. Parentheses, x stays x, minus, and the x1 is going to be 0 in this case. So we plug everything in, and now let's simplify. On the left, we're just going to keep y minus 5 for now. Let's distribute the 1/3 through the group. We're going to get 1/3 x, and 1/3 times 0 is going to be 0, so we'll just leave that off. Okay, next I'm going to move this number to the other side so that we get y alone, plus 5 and plus 5, and we're going to get y equals 1/3 x plus 5. I'll just rewrite that here. Y equals 1/3 x plus 5. And that problem is done. Alright, so I'm going to pause this video and we're going to look at another one. I put another problem on the board. Let's take a look. We want to look for an equation that passes through point 0, 5 and is perpendicular to the equation y equals 1/3, that should be x, plus 4. You'll notice that the point and the equation are the same as in the last problem. It's just that the difference is this time we want an equation that's perpendicular. Alright, so first let's start off by determining the slope. Now, if this is the slope of this equation, and it's in slope-intercept form, which it needs to be to get the slope, 1/3. Well, for it to be perpendicular, what do we need to do to the slope to get a perpendicular slope? We have to take the opposite reciprocal. So that's going to be The opposite of 1/3 is negative 1/3, and the reciprocal would make it negative 3 over 1. So let's just throw that here. M is equal to negative 3 over 1. You could say negative 3, but you could put it over 1. I usually sometimes do that because it's slope. All right, so then also, I always like to, and recommend my students to do the same, to always start off with the point slope formula. So just write that out. Say it with me, y minus y1 is equal to m times the quantity x minus x1. And then we'll plug in with what we're given. So remember, y stays y. Let's write that. And 5 is y1. So let's put that in for y1. Equals, we determined that the opposite reciprocal of this would be negative 3. Let's just make it negative 3 for now. Quantity, x stays x, minus 0. And now we're going to distribute and simplify until we get to the final equation. Rewriting y minus 5 equals negative 3 times x is x. Negative 3 times 0 is 0, so we're not going to write that. Now let's move the 5 to the other side by adding 5 to both sides. And we're going to get y is equal to negative 3x plus 5. And that's the end of that problem. So again, I'm going to pause this and put up another one. Okay, I put up a third and final problem on the board for this video. So let's take a look. In this problem, there's a few things we're going to do. We want to give the equation of a line that passes through these two given points, negative 1, 1, and 5, 7. Okay? We want to report our answer in first, slope-intercept form, and I'm also going to show you how to give the answer in standard form. So that way we get a little practice on converting from one form of the equation to another, because a question that you're asked might ask you to answer in either of those two forms. Alright, there's one other little detail here that differs from the last two that we did, and that is what's given to us. In this problem, 2 points are given. In the last problem, we were given 1 point and a slope. So when we're given a point and a slope, we could go right into the point-slope formula, more or less. We did have to do a little figuring out because there was parallel and perpendicular lines, but that was easy. But in a case like this, we have to start by calculating the slope first. So what we're going to do is use the slope formula. M is equal to y2 minus y1 over x2 minus x1. And we're just going to plug in and determine the slope. So if this is 0.2 and this is 0.1, then we're going to do 7 in for y2 minus y1 of 1 over x2, 5, minus negative 1, which is negative 1. Okay, and the top 7 minus 1 is going to give us 6. And then 5 minus a minus or plus 1 is again going to give us 6. So we can make that slope of 6 over 6, 1. Let me just sneak that in there. Alright, so now we have the slope, 1, and we have 2 points. Does it matter which point we use to put into the point-slope formula? No, just randomly choose. If you can, try to pick an easier point. I usually go for the ones with the smaller numbers, but it doesn't really matter. So randomly, I'm just going to choose this point with this slope. So now I'm going to write the point-slope formula. Y minus y1 is equal to m times the quantity x minus x1. And now we're going to fill in. Y stays y. And if we're using this point, y1 would be 1 equals, we determined that the slope is this 1, so this 1 is going to go here for m. Parentheses, x stays x, and minus, and in this case, this is our x1, and since we have minus of a minus, I'm just going to make this plus 1. Alright, let's distribute this through. I'm going to rewrite y minus 1 on the left. 1 times x is x. 1 times 1 is 1. Now let's move this number to the right by adding 1 to both sides. And we're going to get y is equal to x plus 2. And I'm going to circle that because this is our answer in slope-intercept form, y equals mx plus b. In this case, m is 1, and that's why we have it unwritten 1, because usually for a coefficient 1, you don't write 1. But it's still slope of 1, and this is mx plus b, where b is 2. But we also want to put this in standard form. So let me rewrite the slope-intercept form. And if we want to put this in standard form, if you remember, standard form means the terms with the variables are on the left and the constant, or the number, is on the right. So to do that, we only have to make one change. Let's subtract x from both sides, and we're going to have negative x plus y is equal to 2. And now we have both terms with the variables, the x term and the y term on the left, equal to a number on the right, and that qualifies as standard form. So we have it in slope-intercept form and standard form. To summarize this, if you're asked to give an equation of a line and you're given 2 points, you need to start by putting those points into the slope formula. Calculate the slope, put it into the point-slope formula, and use one of the given points to put into the point-slope formula. And then simplify, and then put it into the form of the equation that the question is asking. So that's all for this video. I am going to cover a couple more similar questions that deal with when you're given a point and you have to give the equation of the line that will be either related to a horizontal or a vertical line. I'll be doing one each of those on Facebook and on Instagram. So you could go to those pages to check those out. But anyway, thanks for watching this video. If you found it helpful, please give a thumbs up. Please share with your friends and subscribe to the channel so you can be alerted when new videos come out. And other than that, I'll see you next time.